So in this video, I'm going to look at roots of equations. On the roots of equations, we can determine how many roots a quadratic equation has by looking at what's called the discriminant, and this is the part of the quadratic formula that's inside the square root. So our discriminant is b squared minus 4ac. Now in the case where we have equal solutions, which we would get from the quadratic x squared minus 4x plus 4, which factorizes into x minus 2x minus 2, you'll know from the factorizing technique that x will equal 2. If you put in the values into the discriminant, you would find that b squared minus 4ac was equal to 0. And that kind of gets rid of this part and just gives you one solution. So I'll show you that. So the b squared is minus 4, that's got to be squared, minus 4 times a, which is 1, times c, which is 4. And that gives us 16, minus 4 squared 16, minus 16. So remember that's plus 16 when you square it. And that shows you that when b squared minus 4ac equals more, the solutions are equal. Now had b squared minus 4ac been larger than 0, we would have got a plus and minus part added on to the minus b over 2a, and that would have given us two solutions, different solutions. And if b squared minus 4ac had been less than 0, we would have had the square root of a negative, which gives no solutions. So they are the three cases then. Two solutions, one solution, or 0. So we can straight away transfer that understanding into some problems that regularly come up on the C1 paper. So in this particular, in fact I'll start with something slightly easier, we'll go with this one first. No, we'll stay with this. So with this particular problem, I've been told that if x squared plus kx plus 8 equals k has no solutions, then show that k satisfies this inequality. So first of all, before I can work out my values of a, b and c to put into the discriminant, I must make this equation equal to 0 by bringing the k over. Okay, so the k has just been moved over across. So we can see that a would be 1, that's the coefficient of x squared. B would be k, and c would be 8 minus k. Now if there are no solutions, the formula tells us that b squared minus 4ac therefore would be less than 0. So my b squared is k squared minus 4 lots of a, and a is 1, so I don't need to write that, times c, which is 8 minus k, less than 0. If I expand that, I get 8k squared minus 32, and I get plus 4k minus 4 times minus k. And that really is the answer. I'll just write it around the way it was presented. K squared plus 4k minus 32 is less than 0. And that was a 3-mark question on a C1 paper. So if we now go to the 4-mark question, so in this particular problem, which is quadratic equations, we've been told that x squared plus 2px plus 3p plus 4 equals 0, then find the value of b so that given quadratic has equal roots. So for equal roots then, b squared minus 4ac will equal 0. So a again is 1, b is 2p, and c is 3p plus 4. So we substitute that in, so we've got 2p squared minus 4 lots of a is 1, we don't need to write the 1 times c, which is 3p plus 4. And that must equal 0. So we really have to solve this quadratic equation to find the value of p. So we'll expand, we'll square the 2p, or p squared, we'll expand the brackets here, minus 12p minus 16 equals 0. Well, I can see that we've got a common factor of 4 to all the numbers here, so we divide through by 4, gives me p squared minus 3p minus 4 equals 0. So I will now factorise that quadratic, it's a fairly straightforward one to do. P minus 4 means p plus 1 equals 0. And it says find the value of p, so we have equal roots, so the value of p that I'm going to take will be p equals 4. Now there's probably something that I probably didn't write down actually, but we were probably told somewhere that p had to be greater than 0, which would have directed me to the positive answer. So basic technique then is to know the condition that applies to equal roots, to substitute in the coefficients of a, b and c and solve that equation. And that's two examples of roots of quadratic equations that support the C1 exam.